Hello everyone, and welcome to our weekly seminar series sponsored by the Institute for Sustainable Solutions. Tonight's title for the presentation is Providing Sustainability, the International Development Monitoring Initiative, and the speaker is Dr. Evan Thomas from the College of Engineering. Before I introduce Dr. Thomas, I would like to make a couple of announcements. We'll have half an hour for Q&A sessions, so if you have any questions, please come up to the mic as we are going to stream the presentation. There will be also a reception following the lecture, so please stay and continue the discussion over some light refreshments. The students can come and see me after the talks, and I can hand out the weekly reviews, and we can talk more if you have any questions about the course. Dr. Evan Thomas is an assistant professor and the director of Suite Lab in the College of Engineering here at Portland State University. He's also a faculty fellow with the Institute for Sustainable Solutions. His research and teaching interests include developing sustainable life support systems for spacecraft and the developing world. Evan is also social enterprise executive as the founding executive vice president of the MENA Energy Limited. MENA Energy is the first organization in the world to secure United Nations carbon credits for the treatment of drinking water. Prior to joining PSU, he worked as a civil servant with the NASA Johnson Space Center in Houston, Texas for 6 years. At NASA, Evan was a principal investigator and project manager in the life support and habitability systems branch, working on concepts for sustainable Moon and Mars spacecraft. He holds a PhD in aerospace engineering sciences from the University of Colorado at Boulder, and he's a registered PE in the environmental engineering in the state of Texas. Please join me in welcoming Dr. Thomas.
Thank you all. So I'm going to be talking to you today about what we do in the Suite Lab. The Suite Lab is the Sustainable Water, Energy, and Environmental Technologies Lab in the College of Engineering. We are tech geeks, we're engineers, but we focus on a lot of the softer side of international development through some of our hardware. So we do things like water, energy technologies, sanitation systems for developing countries. We also still maintain a connection with NASA through some of our water microgravity fluid management systems and some other technologies. But our real interest is through improving models for an international development, and that's what we'll be talking about today. Spresa already mentioned my background, so I'll just talk through a little bit of that. I came to international development efforts a little bit backwards. I wanted to be an astronaut. And so I spent a lot of years following the right path to become an astronaut. I worked at NASA for 6 years doing life support systems. We were concerned with microgravity fluid management, water recycling, fire suppression and detection in space, habitation systems, and different technologies that are necessary to keep people alive and healthy in the spacecraft environment for a long period of time where you have little resupply, infrequent resupply. As well-trained as astronauts are, they still only have surface-level training in any given system, especially some of the more the life support systems where they just have to turn a few knobs and make sure they get clean water and don't necessarily have the training necessary to tear apart their water recycler. So these things have to work for a long period of time with little maintenance, little resupply, and limited training. This is how we test our systems. There's only a few ways to test systems without going into space. So what are they? Well, first of all, what's different about space when you're dealing with fluids? You float. Why? So what about gravity? So what is it that when the astronauts are in space and they're floating around, what's happening to them? What are they doing? There's a lack of gravity? Anybody have another guess? So what's happening here, we're on what's called the Vomit Comet. It's the C-9 aircraft, and it's flying what are called parabolas. It's flying straight up in the air, it comes over the top, and then it flies straight down. And then at the bottom, it pulls out. And so we're weightless, like as you see in the pictures and the video here, for about 30 seconds at a time. And then when we pull out, we weigh 2 Gs, so we weigh twice as much as we normally do. And in those 30 seconds, we are weightless, and we're able to test our experiment. So what's happening on this airplane right now, and is it the same or different as what happens on the space station or when the astronauts go to the moon? Anybody have a guess? Anybody a physics major? Is it the same as what's happening on the space station? Come on, I showed this video to elementary school students. They're willing to guess. Not the same. It is the same, but good guess. It is the same. So what's happening on the space station is that the astronauts are in free fall. They're literally falling towards the Earth just as fast as the airplane is falling towards the Earth, but the Earth is moving away from them at the exact same rate. So every 100 feet they fall down, they actually move forward, and the Earth curves away from them another 100 feet. So if the Earth was flat, there'd be no such thing as weightlessness in space. And the airplane's doing the same thing. The only problem is we're not going fast enough to be in orbit, so we'd hit the ground if the airplane doesn't pull back out again. Here's another question for you. And I asked this question of the pilots one time when we were flying. So we were weightless for 30 seconds at the top of the parabola. Then we pull out, and we weigh 2 Gs. We weigh twice as much as we normally do. So what would happen if the pilots pushed it into 40, 50, 60 seconds of 0 G, and then we were to pull out? What would happen? Would we feel 3 times as much as we normally do, or would we just feel 2 Gs for twice as long? What do you think would happen? Anybody have a guess? 2 Gs for twice as long? So I asked this question of the pilots, and the answer was the wings will shear off. And the reason is that we're going so fast when we come over the top, we're nearly supersonic over the wings. And if the air goes supersonic over the wings of a subsonic aircraft, it goes unstable and the wings would shear off. So the answer is we just can't do it. So while I was at NASA, we founded a company called Mana Energy Limited, which is a for-profit company. It's a social enterprise where our aim is similar to nonprofits, where we're aimed at reducing poverty in developing countries, but we do it through some business mechanisms that I'll be talking about. What the Sweet Lab is focused on is improving sustainability through accountability in international development. The word sustainability has been thrown around a lot. We use it here in the Institute. It's used all over Portland. It's a great word, and it is a meaningful word, but sometimes the tangibleness of it is lost in some of the PR. Greenwashing or just saying that you're sustainable really means that you are. And it's hard to actually define sometimes what sustainability really means, especially in international development. What we are trying to do is we believe that sustainability is inexorably tied to accountability, where we want to provide feedback and hold international development organizations accountable and give them tools to be accountable for the results of their projects. Because a project is not sustainable if you're using funding from one source, implementing a water, sanitation, energy infrastructure program, walking away from it, and it falls apart after a few years. That's pretty much the antithesis of sustainable. So we think that there is a need for metrics and data that tell us the performance and use, very simple things, whether or not it works and whether or not people use it, of these programs. So here's how things currently work now. There are project implementers that have the money, or they get the money from donors, from USAID or from the Gates Foundation or from Rotary clubs or churches or private donations, and they go and do a project. A project could be a water project or sanitation or energy, cookstoves, PV lighting, a footbridge, and then they want to know, they're doing these things because they want to have an impact on local communities. These aren't projects for the sake of having projects, at least they're not supposed to be. They are technologies and tools that are meant to build capacity and to result in tangible public health improvements and livelihood improvements in developing communities. So with a water project and a sanitation project, we ultimately are after reduced incidence of diarrhea. With a cook stove program, we're after reduced incidence of indoor air pollution and upper respiratory disease and more money in people's pockets because they're saving costs that they would normally spend on wood fuel. With infrastructure, we're after things like better living conditions or transportation, where we will connect a village across a river to a market or to a school or to a healthcare facility. So that's why we do these projects, and those are the impacts that we seek. But we often we struggle to actually be able to measure that impact and know if one program is working or not, and if the mechanisms for implementing the programs are working. And this linear structure is common. There's a few different twists on it. Some have microenterprises or microfinance, where there is participation on an economic level from local communities. There's often talk of community participatory development, where the local communities have buy-in. Sometimes it's more real than others, but they're expected to put in, to guide the process, to guide the work, and ultimately take responsibility for the programs. But the measurement need is the same. Whatever mechanism you're using for implementing these programs, you still want to measure whether or not you're effective. Right now, the model for measuring this is shown on the bottom. It's expert surveys, where you, under the best of circumstances, you hire a trained expert who goes and tries to collect as unbiased data as possible on whether or not you've accomplished what you said you were going to accomplish. And the experts will go into the communities, they will do interviews, they will do surveys, they will examine the technology, they will try to look at impacts like reduced diarrheal illness, and then they come back with a report on whether or not things are working. Unfortunately, this mechanism doesn't work. We don't think it works, which is why we're offering a solution that can augment this process. The challenge with expert surveys is that even under the best of circumstances, they're snapshots in time. They represent one data point, maybe a few days or a few weeks of time in a village, and then you don't go back and check for months to years or perhaps never again, and these reports sit on shelves. So even if they're accurate, they still end up being these snapshots in time. And more often than not, they're not really that accurate. There's a big courtesy bias that's inherent in these surveys, where recipient communities will often tell the experts what they think they want to hear, or what they think the donor or the project implementer wants the result to be. You know, of course I'm using that sanitation system. Of course I'm using that cook stove. And so there's a lot of bias inherent. And we see this because we see surveys coming back saying everything works, and then we see competitors reporting on other programs showing, actually, no, you guys aren't doing that great. Here's our evidence. Here are our anecdotes on what's working and what's not. And as a result, the international development community is rife with this infighting. There's these debates constantly. I just got back from a conference in Seattle where this was in big evidence, where the little guys are disdainful of the big guys are disdainful of the little guys, the competitors are disdainful of each other, and it ends up being power of personality, power of anecdote, who you know, and there's very little data to back up these programs. At least there's a weakness. I don't want to say that it's universally a problem, but we've at least identified a weakness in the sector. So our approach is purpose-built instruments that monitor these technologies, monitor whether or not people are using a given project and whether or not that project is actually performing. So with a water treatment system, we want to know, do people use the water system, and is it actually effective in cleaning the water? With a cook stove program, we want to know whether or not people are using the cook stoves and if it's actually reducing emissions, reducing fuel use. So does it work, and do people use it? And then the results of this data doesn't replace surveys, it informs the surveys. We're able to go back to the experts, show these results, and help improve designs for technologies, designs for implementation models, and designs for these same surveys. So here's how our technology works. We have something called SweetSense, which are our sensors. They're purpose-built. We didn't set out to invent anything. I'll talk a little bit about the technology, but there were not really sensors off the shelf that were appropriate for this international development application. So we've spent the past year developing this new technology and implementing it. The sensors measure things, usage and performance of these different projects locally, and then wirelessly send that data over the internet via the cell phone networks to our web-based system that processes the data. It's called Sweet Data, and this is where all the data processing is done, and we're able to output to our partners to the project implementers what's working and what's not, where there are strengths, where there are weaknesses. So the technology, our technology, SweetSense, is low power and low cost. We're able to run off of a couple batteries for 6 to 18 months. And we're running right now, even during the prototype stage, we're at about $100 per unit. And that's still with all the messiness of doing prototyping. And part of the innovation is we only log based on triggered events. So this is something that's a little bit more interesting to the technical folks, to the engineers or the electrical engineers and the software folks that show how we're different from existing data loggers. But suffice it to say, there are innovations that we've done that make this purpose-built for developing countries and for these types of partners. So we only log during events. Most of the time a latrine's not being used. Most of the time a cookstove's not being used. There's no need to constantly log the data. Likewise, when it is being used, we want high-resolution data. We really want to know what's going on. So we sample constantly. We're always looking at the technology, but we only log when events are triggered, when the cookstove's turned on, when the water tap's opened. And then the data is sent over the cell phone networks and processed on the cloud. So the heavy lifting, the real statistical analysis, the parsing, the data reduction is done automatically online rather than locally, so we don't chew up too much power locally. And then we can send new parameters down. We can actually influence and control these sensors remotely, both automatically. We can recalibrate them and re-trigger them, and we can manually reset them without actually touching them again. And we've been able to file a patent on this now, along with our partner, Stevens Water Monitoring. Stevens Water is a Portland-based company. They're 100 years old. They grew up here in Portland making mechanical water monitoring instruments and then graduated into the electrical field 20 years ago. And they've been doing this with us pro bono. We cover their expenses on the material costs, but the technology has been developed as a strong volunteer partnership from Stevens Water. So this is the different versions we have. We have flowmeters that are SweetSense. We have versions for what's called the life straw, and I'll talk about that in a little bit. We have versions that go on cookstoves. These are just 3 examples. We actually have a few more iterations. They're all for different applications. And then they, in turn, all talk to SweetData, our online platform. This is sweetdata.org. All of the sensor data is pulled in from all of our sensors around the world and processed and displayed here. So you can go to the website and see what sensors where, what it's monitoring. There's some automatically presented data, and then you can download the data and do more in-depth processing if you're after something in particular. So I'll give you a few examples of that. This is SweetSense Flow. This is a dual pressure flow meter we developed with Mercy Corps. Mercy Corps is based here in Portland, but they're one of the leading international development agencies. And in Indonesia, they do a water and sanitation program funded by USAID, and they've installed a number of sites, I think 40 total sites, of hand washing stations that provide clean water and latrines. And they've invested most of their time and effort in behavior change programs where they are trying to get people to use the latrine and then use the hand washing stations afterwards. And Mercy Corps is very smart. They're very savvy. They are a sophisticated aid agency. They're familiar with these challenges I identified earlier. They know about courtesy bias. They know about some of the drawbacks of surveys. But that is, for lack of a better option, what they've been doing. They've been going in, and after they do their behavior change program, they go in and they survey it. And they say, hey, we were just here 6 months ago talking about water and sanitation. Are you actually doing what we suggested that you do? And everybody says yes. And so their reports say that they've had glowing success. They're very sophisticated. They know that there is bias in there, and they're not satisfied with just reporting something that might not be accurate. They want to know what's really going on. So our instruments give them that opportunity. With the dual pressure flow meter, we're able to monitor usage events, pressure head when the tanks are full, how often people are using them. We can actually differentiate between different types of taps. If somebody's using a drinking water tap versus the one in the bathroom versus the hand washing station. We can also correlate this to our latrine monitors. We have another version of SweetSense that monitors the usage rates of different latrines. And we can correlate, we're actually doing this right now, we're correlating the usage of the latrines to the usage of the hand washing stations to see if that behavior change is actually happening. And if it is in some places, but not in others, why? What are those differences? Again, it informs the survey. It doesn't replace surveys, but when we identify trends, we can go back to Mercy Corps. They can dig into it a little bit. If we identify what we think is a problem and they think they have a solution, They go and implement that solution, and then we monitor whether or not that's effective. We can monitor feedback to the program. So there's two sets of feedback. There is both simultaneously the sensor feedback, sending data to the implementers, who then go and revise their program, and then their surveys and the sensors can provide that feedback loop and that iterative process on success or ongoing challenges in programs. This is an example data set. Each bar represents one use of a hand washing station, and the height of the bar represents how much water was used. So, 4 liters in the first time, 2.5 liters in the second time. So this is example data that is automatically provided through our system. SweetSense Fire is another iteration. These are designed to monitor high-efficiency cook stoves. So, as I mentioned, there's many people in the world, 3 billion people, that still use biomass for their daily energy needs. I actually need to look up if that statistic's been revised, because it was always 3 billion, which was more than half of the world's population. But as of Halloween, there's now 7 billion people in the world. So we'll see if it's actually declining or if there's now 3.5 billion people using biomass. But most people use biomass for their daily energy needs, and most people are doing it on indoor campfires. And this causes a lot of problems. Firewood's very expensive. If they're not using firewood, kerosene, LPG, other fuels are also very expensive and time-consuming. It causes soot, black soot emissions, which are very inefficient. The black soot is a leading contributor to global warming. It's actually not as well studied as carbon dioxide, but it's considered likely one of the leading culprits. And a big source of that are these fires that are burned in people's homes all around the world. And the soot also causes upper respiratory disease, which competes with diarrheal illness for a leading cause of death in the world. AIDS, diarrheal illness, and upper respiratory disease switch places for the top 3 leading causes of illness and death in many developing countries. So high-efficiency cook stoves are designed to address this problem. There are different versions, a lot of different versions, that fully combust the biomass. They're able to fully combust the biomass, which makes them 60 to 80% more efficient. So you save between 60 and 80% of your wood. You eliminate that black soot that causes indoor air pollution, and therefore the disease and the emissions. Now, the challenge is there's a lot of different competitors, and there's very few standards for evaluating the competing technologies for high-efficiency stoves. There's pretty much one standard. It's called the Shell Water Boiling Test, and it allows you to compare stoves in a laboratory environment. So you can see efficiency differences very accurately. You can measure efficiency differences in a lab. But this doesn't actually tell us performance over time, and it doesn't tell us adoption rates over time. It doesn't tell us if one stove which is more efficient in the lab is preferred or not preferred to a competitor's stove in a home. It doesn't tell us if one stove that's performing better in a lab degrades over time, melts faster, breaks faster, and causes emissions problems 3 months or 6 months or even just a couple hours or a couple weeks after implementation. And so instead, we're back to those same anecdotes. Oh, I saw so-and-so's stove, and nobody's using it. Nobody likes that stove. I went through a couple homes or a couple dozen homes or a couple hundred homes, and I'm concluding that nobody likes this stove. Or that stove's not used because it breaks, or the pot teeters on it. Tons of anecdotes. The sector is rife with anecdotes that is used in place of actual performance and usage data. That's what's motivating our sensors. The Lemelson Foundation, also based here in Portland, but with international reach, funds technology development. They fund things like high-efficiency cook stove development projects. And they also realize that they don't really have this feedback on whether or not things are used and whether or not they actually perform, the projects that they fund. So SweetSense Fire is designed to try to address this. We have thermistors that monitor thermal efficiency, frequency of use, emission sensors such as CO and CO2 sensors that monitor both of those gases independently and also monitor the ratio change over time that shows its performance. We're able to differentiate between stoves. One big question is, how can you tell the difference if somebody's using their traditional stove or their improved stove? Well, we can tell that. There are signature differences, and we can monitor that over time and tell which stove people are using. And this can again, influence how these projects are implemented, how the technology is designed. And another big piece of this is that it influences another part of my talk that I'll be coming to in a moment, and that's the carbon finance markets. Carbon financing is a mechanism that's used to try to build greater sustainability and development programs by earning carbon credits on things like cookstove projects, in our case, water treatment projects, that you reinvest in the program. But the market is not well utilized for development programs. It's $120 billion a year. I think it's actually bigger than that now. 70% of it's in China. 20% of it is in India. Less than 2% of it's in Africa. And the reason is a lot of the auditors and the methodologies are not compatible with this type of survey work that's done for auditing projects. You can do it. You can do rigorous surveys. You can also do things like have expert third parties spot check your work to try to get out some of your bias. The auditors will come in and do their own surveys. So there are ways to adapt the carbon markets to development programs, but they still lack the ability to read the meter. That's what auditors want. They want to go into a power plant and they want to read a calibrated meter on what you've actually done, how many emissions reductions that actually translates to. Our system for cookstoves gives us that opportunity. We're able to actually measure emissions over time. We're able to actually measure usage over time and adapt that into carbon finance markets. So we haven't done that yet, but we're working with a few partners, including auditors and project implementers and stove designers, including a group called EcoZoom here in Portland that markets the Aprovecho cookstove, to adapt this into a carbon finance mechanism. Here's another version. This is the LifeStraw family, which I have actually one of them here. It's a household scale water treatment system for developing countries. It's purpose-built. You pour your water on the top, you hang it in your wall, and it's an ultrafiltration membrane at the bottom. Comes out about 200 milliliters a minute, which is a pretty decent flow rate for these type of systems, and it meets EPA and WHO standards for microbiological treatment. So we know it works. It's an excellent filter, and it treats all microbiological contamination. What we've done is add our SweetSense system on it to remotely tell us how often these are used, how much water is treated through the system, what the frequency of the backwash interval is. You have to, the red bulb here and the red tap, the filter gets clogged over time like any filter does. You occasionally, as your flow rate decreases, you got to close these valves and pump this bulb a couple times to get rid of the dirty water and the contaminants and regenerate your filter. That requires some training and that requires some attention. And our sensors can actually monitor whether or not people are doing that, or if Vestergaard or other project implementers need to focus a little bit more time on educating that particular component. As you can see here, we're running off of batteries. It's just clear for demos. Really, it's totally covered. The SIM card's built in, so it talks directly to the cell phone tower. There's not another cell phone or another device it talks to. It talks straight to the towers. Antenna built in, and then a magnetic switch. There's nothing external to it that could spring a leak or let water get in. So you just turn it on or off with a magnet. So this is another version that we have for household scale water treatment. So our overall goal is not the tech. We didn't actually set out to invent something. That kind of happened because we're kind of geeky and we didn't see something off the shelf that was really appropriate. But our real goal is standards development. Our real goal is to be able to compare apples to apples different programs. So when my company, Mana Energy, does a water treatment program in Rwanda, and Lemelson Foundation, and we do it with carbon credits, and the Lemelson Foundation funds a cookstove program in Indonesia with grant funding or with microenterprise funding. Those seem like pretty different projects, different environments, different cultures, different people, different mechanisms. But in fact, we're after the same things. We're after improved public health through usage and performance of our technologies. So we can actually measure that and provide data comparability between these projects and see if one mechanism or technology or approach is more or less effective than another. And ultimately, our goal is to inform the standards for humanitarian development programs. So switching gears a little bit, that's what we do in the Sweet Lab. That's the sensor work that we're doing here at the university and with our partners Stevens Water, Mercy Corps, and Lemelson and Vestergaard. But another hat that I wear is with a social enterprise called Mana Energy. Mana Energy Limited is a for-profit. We grew out of a combination of people at NASA and Engineers Without Borders, where I was a volunteer for a long time, ever since we founded it in 2002, actually 2001. So it's a 10-year anniversary now. What MANA does, we're based in Rwanda. Most of our staff, we have 2 Americans and 5 Rwandan staff in Rwanda. We have a few other staff members that are here in the U.S. We focus on community surface water treatment systems, as shown in the picture, high-efficiency cookstoves that we've just discussed. Our particular angle on it are facility-scale systems made out of local pumice brick that we source from the Congo. Biogas generator, and then capacity building. We are for-profit, but we are building local capacity through education activities and through employment. We have full-time employees that we brought on over 4 years ago that we're training in all of these different technologies. And we're able to fund this predominantly through carbon financing. We earn carbon credits for the treatment of drinking water. We consult to other organizations such as Vestergaard to earn carbon credits on their programs, and that's how we're able to finance and sustain ourselves as a business. So this is how you earn carbon credits. As I mentioned, it's a big industry, but it's not well utilized for developing countries. 4.5 years ago, we were naive enough to think that it would be no big deal to take this CDM, the Clean Development Mechanism, and use it for our water treatment systems. We were a little tired about going to Rotary clubs and writing grants and doing donations and even things like car washes and bake sales to raise money for water treatment systems. And so we formed MANA to combine the CDM with drinking water treatment on the premise that in many places around the world, people boil their drinking water with wood. Some boil with kerosene, some boil with LPG. Many people don't do anything at all. They don't do any form of water treatment. But even the people that don't do any form of water treatment often live in an environment where, if they could, they would choose to boil their water with wood. That's the case in Rwanda. It's almost totally deforested. Less than a quarter of the people boil less than a quarter of their drinking water. So a few people are boiling some of their water. And we're able to earn carbon credits on that water by reducing that demand, or that actual usage. So when we install our water treatment system, people no longer have to boil their water. We earn carbon credits on those reduced emissions, which we reinvest in our program. So we're able to pay back our investors. We're able to invest in our program and maintain our program and also expand it. We started 4.5 years ago, and just less than a year ago, we finally registered this program, and it's the first and so far the only United Nations carbon credit for water treatment program. So it was a long haul. A lot of organizations get excited about this idea. Oh, I do something that reduces emissions. We've got this big program, so-and-so, water, energy. We want to get carbon credits for us. How hard can it be? It must just be a couple forms. It's pretty hard. It cost us about $600,000, and it took us 4 years, and a lot of people working for free. So it's not easy, but the returns are significant. You can actually more than recover those costs over time. So our program in Rwanda is the first of its kind. It's pretty small. It's treating water for about 20,000 people, providing local employment, and using our patented water treatment system for communities. Now that's grown for us into working with Vestergaard, the makers of the Life Straw. So this same device, we were hired by Vestergaard about 2 years ago to take our concept, carbon credits for water treatment, and apply it to this device. This device costs about $30 to produce and distribute, which makes it out of range of your average family in a developing country that needs it. So typically what was being done is donations and grants, some microenterprise, some retail work. But Vestergaard was not hitting the scale that they actually wanted to hit. They're very ambitious. They're big and they're ambitious. And so over the past 2 years, we've been working with them. And in June, we finished the distribution of 877,000 of these units. That's a lot. That's a lot of Life Straws. That was container after container being trucked into Western Kenya. We had 4,000 community health workers on the payroll going door to door, hitting 877,000 homes. And there are now over 4 million people, 80% of the entire province of Western Kenya, who have access to one of these Life Straws. And it was a $30 million cost. Vestergaard put in $30 million into this program. $1 million alone was just getting the registration. A piece of that was our fee. A piece of that were the auditors. A big piece of that was the local baseline study and surveys and stakeholder consultations to actually do the work just to get a registered program. The inventory itself obviously cost more than $20 million, and then it cost a few $1 million to have 4,000 people on the payroll. So a significant investment. But thanks to our partnership with them, they're able to earn $12 million a year in revenue on this system that more than repays those costs, pays for a permanent presence in the region. They're going to have 34 district maintenance and education facilities that are getting established right now. And it's the single biggest program of its kind. There's never been another project anywhere close to this scale done by a non-governmental organization. So that's kind of the business side and the tech side of what we do, but there's also a softer side that's our motivation for doing this. And here's one example. This is an orphanage in Rwanda that we've been working at for about 9 years. And the kids here, this picture was taken a number of years ago now, but the kids here at the orphanage, some of the older kids at the time were actually genocide orphans. They were in their 20s, but they still lived there. They had nowhere else to go. The younger kids are AIDS orphans. A lot of them have HIV themselves. These kids are in the picture. Many of them are HIV positive and are taking antiretrovirals provided by the United States. When this picture was taken, there was no electricity, no running water, no sanitation, no clean energy fuel. We've taken care of all of those things now, but at the time they didn't have any of that. The ridgeline in the background is the border with the Congo, which also a few years ago was very destabilized. There was still Interahamwe activity going on across the border. It was a very dangerous region. And using a truck battery and a projector is a little hard to see, but this is a presentation of the Earth as seen from space by Ron Garan, who's a NASA astronaut, and he's a co-founder of MANA. And he wasn't really supposed to be giving this presentation. NASA told him that it wasn't an official visit when he was coming with us, but we were like 5,000 miles away from the NASA legal office. So he decided to do it anyway. And it was a risk. We didn't know, first of all, if the kids would understand what Ron was talking about. Would they care? Maybe resent some of this stuff because they don't have some of those same opportunities potentially. But we thought it was too cool of an opportunity. So Ron, through a translator, JP, was giving a presentation about what it was like to be an astronaut. And afterwards, Ron told me that he got more intelligent questions from those kids than he gets from U.S. congressmen. So that's some of the softer side of what we do, and is part of the motivation when things get frustrating at conferences. All right, kept that a little short for you guys so we can do some questions.
Do you guys ever run into problems with cell coverage for transmitting the suite data loggers?
Yeah, that's one of the interesting things about developing countries now. Just in the past 5-10 years, cell coverage is nearly universal. When we first started working in Rwanda about 9 years ago, it was really limited. Even in Kigali, you couldn't really get a cell phone signal very easily in some places, and definitely not out in the villages that we work in. But since then, Rwanda now has, I think, 97% cell phone coverage. Kenya's over 90%. Indonesia's over 80%, and Indonesia's enormous. So pretty much everywhere we work, there is cell phone coverage. And so even though people don't have running water, sanitation, electricity, roads, they do have cell phones, and we are able to get 3G coverage. It's been a great equalizer too. The mobile, there's a lot of work that sounds similar to what we do around mobile apps and mobile data collection, where people are filling out surveys and filling out and doing things like M-Pesa, which is mobile banking. And this has been big in developing countries, and it's great stuff, and it's really helped with things like violence monitoring, with markets monitoring to see if when you're going to take your crops to market. It's still missing that piece of the objectiveness of instrumented data collection, which is what we are trying to provide.
Hi, I have a question for you about CDM. You talk about carbon for water. What about the part of the fission stove? For example, DR and Haiti are right now working on that and trying to have program of activities on efficient stoves. And you could try to measure, I know it's very hard, and forestry projects are very hard to pass in CDM, but you could try to measure the decrease in deforestation, the decrease in the wood use to boil, to cook, and all that stuff. Have you thought about that? Are you thinking about that? Have you done anything?
Yeah, actually, so there's a few things. So MANA doesn't directly earn carbon credits yet on our cook stoves, although we're working on that now. So I didn't say that we've done it because we haven't done it yet, but we are working on that. We're actually registering a gold standard program now for our cook stoves and our water system. So we earn in the same location, we put in our water treatment plant and our high efficiency cook stoves and earn credits on both technologies. There are a lot of other groups that do, well, not a lot, a handful of other groups that do earn carbon credits on high efficiency cook stoves. Some of our friendly competition, their programs are around high-efficiency cook stoves for carbon financing. So there are people doing that. We also do it. Our particular niche, our claim to fame is around the water treatment. But, of course, you can earn CERs, VERs for cook stoves. Now, the other part of your question is how that relates to deforestation and how that relates to RED. RED is the sister mechanism to CDM. CDM is set up to do project-level work for energy and energy efficiency and earn credits on a project level. The sister mechanism is called RED, which is reforestation and afforestation and preventing deforestation on a bigger scale. So it's working with national governments or big companies to protect big standing trees of forests or rebuild forests. And a real challenge, as you identified, is monitoring trees, because it's actually easier to monitor a cook stove over a few years than monitor whether or not a tree doesn't get cut down and burned over 30 years. It's really tricky. But there is a linkage. With our with Vestergaard, actually, we are expanding now to do this same program in Indonesia, where people really do boil their water. They use huge amounts of wood fuel. In Sumatra, South Sumatra and Lampung, we're doing a 3 million household program with them now to impact about 12 million people. And those folks right now are consuming huge amounts of wood fuel. As a result, they don't have that much incidence of diarrhea, but they do have incidence of upper respiratory disease. They do have deforestation. They do have a lot of cost. And there are RED programs going on simultaneously. So there are informal linkages. A little bit more formally, I was just talking with a group called Conservation International yesterday, which is one of the big conservation organizations. They're on par with Nature Conservancy. And their main interest is conservation, and so they are engaged with RED and with deforestation efforts and freshwater system efforts, but they also do development because they know that a lot of conservation in developing countries, it's necessary to engage with human needs. People are deforesting because they need the trees as a service. So if you provide cook stoves or water systems as an alternative, you're able to address some of your conservation interests. So we were just chatting yesterday about some of those more formal linkages between conservation efforts and development efforts in terms of carbon finance.
Excellent. And my last question would be, how much should be a unit, one of the stoves, the fission stoves?
In terms of carbon?
No, money.
Oh, money,
right. Per
so,
country, for example, you need to have a certain number of them to make a difference if you want to do the CDM. And that's how some of these countries are looking at it. But as you said, the investment is a lot.
Right.
So how much would it be?
Right. So a lot of these stoves, they range from $5 to $40 depending on the stove. If you have a locally produced, cheaper materials, maybe lower quality construction, maybe $5 per stove, but it'll probably melt over time. And people do that deliberately. They'll have a cheaper stove that you replace more frequently rather than a stove that is out of range of an average family. There's other stoves like EcoZoom stoves or EnviroFit stoves that are maybe $30 or $40 by the time you deliver them. But even those, similar to the Life Straw, that's inaccessible for many families. Even if you do things like microcredit, microfinance, or subsidies, it's still difficult to get those out there on a retail market. So with carbon financing, you're able to either highly subsidize those or have them given away for free, and in exchange earn those carbon credits and build that scale. So Vestergaard, before this, their biggest project was on the order of tens of thousands of Life Straws, which is still big. This is nearly 1 million Life Straws because of carbon credits. Likewise with cook stoves, there's a number of groups, POAs and individual projects that are doing much larger scale implementations because they can't afford it, because there are investors. In our company, MANA, we are looking at different investors that we actually are able to return their investment to them with interest because we see those returns from carbon financing. There's another thing, but I forgot.
You'll remember. A question from online, Evan, related to end of life for products like the Life Straw batteries, or if it breaks, the Life Straw is new, so how would you deal with that? Repairs and other parts of the technology, do you empower them to repair it themselves, or how does that work?
It depends, and I remember now what I was going to say. Okay, so repair and maintenance, everything breaks. Our sensors break, the Life Straw breaks, cookstoves break. Even if they don't break, they eventually are consumed. Actually, that's much more what is likely to happen with the higher quality cookstoves and something that's a high quality product like the Life Straw. It'll get consumed. The filter will eventually clog over a period of years. We rate it for about 3 years of use, of typical use, which is actually a lot. That's 18,000 liters of treated water. But eventually you have to either repair or replace it, and there have to be mechanisms in place. That's another reason why we do the carbon financing. We're able to engage, recover those consumed Life Straws, properly dispose of them, recycle pieces that can be recycled, dispose them in an environmentally safe or responsible way rather than letting them litter communities, and then have the resources because of the carbon credits to replace those units. So through carbon financing, we have an answer to that question. We're able to replace those units and recover them over time. Now, other mechanisms also struggle with this challenge. How do you actually make sure that people can afford it over time? They try to build an aspirational quality, try to encourage communities to save money from their saved wood or saved healthcare costs, try to create local businesses, retail outlets to, again, another part of the hint in the question is local maintenance. Appropriate technology is often interpreted to being something that can be produced and made locally. Now, that approach was suggested 10, 15 years ago in response to the top-down level of aid that was done for 50 years before that, where you did massive infrastructure programs, water plants, power plants, roads, dams, and things slowly fell apart because you didn't have the local capacity, local tax revenue to maintain those systems. So the pendulum swung the other direction, and participatory development and appropriate technology became the mantra of development agencies, from the small to the big, where you need to build everything out of locally sourced parts only, ultra simple, easily maintained. But I don't entirely subscribe to that. I don't oppose that, but I don't subscribe to it wholesale. I think it actually needs to be a mix. There's some high-tech things that really do make sense for developing communities. Cell phones is an example. In our embodiment in Rwanda, we use ultraviolet disinfection, which is 20,000 times more energy efficient for boiling water than wood. So there are high-tech elements that are very appropriate, and you have to be careful to not be just as patronizing as what you're saying you're not doing when you are working in a community and saying you can only have this low-tech thing because you can't maintain the higher-tech thing. That can be just as patronizing as the people swooping in to implement something they think a village needs. That's usually given as the example of why you do participatory development and local capacity building and appropriate tech. But that approach can be equally troubling in some cases, so you have to be careful. The other thing I was going to mention, because if nobody's going to ask the question, there's still people thinking about it, is the issue of free giveaways. We do free water with these systems. There are Cookstove and Vestigard is a free giveaway of the Life Straw. And this is something that there are development experts who are very experienced who disagree with this approach, who believe that free giveaways corrupt the market, that make it difficult to actually do a market-based implementation of water or energy systems, that there is not buy-in, there's not local community adoption of these technologies if you're giving it away for free. If it's for free, that suggests maybe it has no value. And that is a debate, that is an honest debate, but it's not a closed debate. There's a lot of evidence to support that giveaways or even incentivizing things like vaccinations, water treatment, energy systems can lead to much higher adoption rates. So one thing I would just caution if anyone's thinking about it is that the giveaway model is not free and clear the best way of doing it, but it's also definitely not considered the worst. There's a lot of debate on what the right model is. And this comes back to the motivation for our instrumentation. We want to actually know what models are working and what aren't. We are agnostic about it. When I'm wearing my MANA hat, I think carbon credits are great, and I think we are trying to improve that model. And when we identify weaknesses in how we do it, we try to respond to those. But generally, I think it's a good idea, because that's why we're doing it. With the instrumentation, with the PSU, the academic hat on, we're more agnostic about it. Is carbon financing working on our Rwanda water treatment program or a cookstove program in Mexico? Is a microenterprise program working in Indonesia for water treatment? What are the similarities, differences between these models, and how does that actually result in what we want to do, which is improve public health and improve livelihood?
Thank you. After hearing you talk, I understand how you get reimbursed for carbon credits, but how does the money enter the carbon market, and do U.S. companies also participate in that?
So part of the reason that a lot of Americans aren't familiar with the market, some people I talk to about carbon credits think it's monopoly money and we just are making this whole thing up, is because the U.S. didn't ratify Kyoto. So the U.S. does not participate in the Kyoto Protocol because we don't have to. The Kyoto Protocol is a binding treaty that almost every country in the world agreed to, and it created the Clean Development Mechanism. And the Clean Development Mechanism is a formal instrument to allow buying and selling carbon credits between signatory countries. And signatory countries then devolve that responsibility, which is a legal responsibility, international legal responsibility, down onto their industries. So Sweden will tell the energy sector that they have to reduce their emissions by a certain percentage over time. And then that industry has the choice between reducing their emissions by improving their own efficiency, or buying that difference from another sector that is able to do those efficiency differences. So the people that are buying our carbon credits are people that have to buy carbon credits to comply with treaty obligations in many cases. I use Sweden as the example because they actually are buying our credits out of Rwanda. Now, they believe in the humanitarian element of this program. They believe that they want to invest in a project like this and not some other competing projects like a power plant. But they also need these carbon emission reductions to comply with their obligations as a country. There also is several voluntary mechanisms. I got my plurals wrong on that. There are several voluntary mechanisms, including the gold standard, which is what we use in Kenya. In Kenya, we're using a voluntary mechanism, and the buyers here, in this case it's JP Morgan, are buying them and selling them to companies that are positioning themselves in the carbon market. So some of them are doing it for corporate social responsibility, another form of charity or aid, and for PR values, but a lot of them are doing it strategically to position themselves in a certain sector for when compliance mechanisms come down on their particular field. So even the voluntary mechanism is closely linked with business motivations and regulatory motivations, not just charity. Did that answer your question? So I don't know if I mentioned this, one carbon credit represents 1 ton of carbon dioxide that's either removed or not emitted to the atmosphere. So you convert everything into CO2 equivalents. So if you're burning methane, every ton of methane you burn actually gives you 20 carbon credits, because methane is 20 times as bad for the environment as carbon dioxide. So you get 20 for one. When we burn firewood, for every household that we treat water for, we're able to earn between 0.5 ton and 2 tons of carbon emission reductions a year. Any other questions?
Hi, thank you for the lecture. Is the carbon credit things is like same as the carbon emission permit that you can actually trade between companies and companies? So like, for example, one company produce more, and then so you buy it from the other company as an investment. Is that how it works the same way, or is
it's very similar. So the carbon markets is based on a permitting system that was done in the United States for reducing emissions that were causing ozone depletion. So and acid rain issues too. Mm-hmm. So the EPA regulated permits for 20 years or something like that to reduce acid rain and reduce ozone emissions, and that's what the markets are based on. So there's in the political discourse in the U.S. now, there's a big backlash against cap and trade or taxes or anything like that. But it's funny because we actually invented it.
Okay. Also, I'm just wondering, it's like when you like do those projects, like what is the, or sure it's a governmental, if you do kind of similar project in the developed country, like those kind of monitoring system, like it's hard to actually install those systems. Like for example, in the energy sector, they install those monitoring system for the to see electricity use. It's like really hard to actually do those in developed country compared to developing country.
So actually, you're asking about domestic implementation of our sensors?
Yes.
So I gave Stevens Water credit for doing this work pro bono, but they also have a business motivation. A lot of the work that they've been doing in partnership with us is because they also see a market for these sensors locally. Their traditional market is the USDA, the EPA, the City of Portland, Metro, to remotely monitor water quality, to monitor soil quality or soil moisture, to monitor snowpacks. They see an application for what we've developed with them in their traditional market segment. So, our motivation and interest has been the international development angle, but we're looking to commercialize this with Stevens for domestic applications too. And you mentioned energy efficiency in buildings. That is one example that we're also talking about.
Okay, because why I'm asking this is because I'm really interested in like why actually a lot of projects is done in the developing country instead developed. Because like for example, reducing carbon CO2 or something in developing country is necessary because they're growing and they have huge population and they have they need water use too. It's a lot good side, but what I want to know is just like what can I say? It's but they actually sorry, I forgot what I was. But when you do those in developing countries, just I think they don't use as much as we do. So in that way, so I think maybe a lot of programs should be actually started in developed country instead developing country.
Right, for emissions reductions.
Yes.
And there are many, many projects in developed countries that are aimed at emissions reductions. It's called Joint Implementation, JI. It's another sister to CDM and RED. And that's what most of the market is. It is power plants, more efficient power plants in Western Europe or in other countries. A big emphasis is around more efficient power plants in China and India, which are both countries that are growing rapidly and have much greater energy needs in the past 10, 15 years. And so there's a ton of work around emissions reductions in developed countries. There's actually very little work done in applying these markets to truly least developed countries like Rwanda. So we are one of the few organizations that are trying to adapt it for that environment. And to be honest, our motivation is around public health and humanitarian needs, and secondarily, the climate change mechanisms. I mean, of course, we want to contribute to reduced impacts on climate change, mitigating climate change impacts, mitigating emissions, but our original motivation was to find a sustainable way to do our public health programs.
Thank you.
What do you think the prospects are for extending a program related to the Kyoto Protocol at its expiration? But in some sense, this is a political question, I suppose.
Yeah. So the Kyoto Protocol expires at the end of next year, and I don't think there's any reasonable hope of another extension of that commitment period. That was supposed to happen in Copenhagen. That was huge. The PR around it was enormous. The cover of The Economist called it the conference to save the world, and it totally fizzled for several reasons. Then it was supposed to happen in Cancun, and it didn't. There's going to be another meeting in December in South Africa, and there's really no hope anymore of a big system that the United States and China and India and Japan and Europe all participate in that has one umbrella for reducing emissions. So we can pretty much give up on that. Now, that being said, we have seen increased demand for our carbon credits in the past few years. 4 years ago when we started, everyone told us that the biggest risk, our biggest single risk was going to be if there wasn't a follow-on to Kyoto, and then all the demand for our carbon credits would dry up. And now, 4 years later, Kyoto is disappearing, but demand has increased. More people are wanting our carbon credits because of these multilateral agreements, because the EU ETS market has agreed to honor credits from given projects through 2015, because Australia is working with Indonesia on how they're going to do a permitting process, because Japan is working with several other countries. So it's a lot messier. It's a lot more complicated. It would be, in some ways, easier to have one mechanism, but a lot of countries aren't waiting for the U.S. and China to agree on how to do this with each other. A lot of countries are doing multilateral and bilateral agreements to continue to do emissions reductions trading. And it still has regulatory power. The EU can still have a regulatory system. Australia just implemented their regulatory system. So it still has the power of law and still has a demand for these carbon credits. It's made it also more interesting. We're getting people coming to us from different places with different motivations for our credits. And it's also increased the demand for the voluntary credits. Everyone also said that the voluntary mechanisms are going to go away even faster if Kyoto doesn't get renewed, because who wants voluntary credits if you don't have to buy them? All these multilateral agreements has made things a lot more fluid, and demand for the voluntary credits has also increased. So from an outside perspective, it'd be nice if there's a follow-on to Kyoto. I really think it's needed. But within what we're doing as a business and what our partners are doing as a business, we're not that concerned with it. Surprisingly, we were told by all the experts that it would be our biggest risk, and it isn't.
Hi, I work for one of the voluntary carbon standards that you are mentioning, called the American Carbon Registry, and that's actually housed within an international nonprofit called Windrock International. So it has, the registry has, shares a lot of the same kind of sustainability motivations, and is mission-driven, being a part of that larger organization. And we're looking to soon to approve a methodology for cookstoves, but are looking at other monitoring mechanisms, such as remote systems like you just presented on, mainly because of all the reasons that you talked about as far as data availability and all the benefits, but also because we have project developers who are maybe working on a smaller scale, don't have as much pro bono contribution, and find the survey requirements of existing methodologies just cost prohibitive, because their locations are out in the middle of forests. They have it takes a lot of time, a lot of money to get to these places and do the surveys. So I just wanted to see what kind of cost benefit analysis that you might have done with the new technology availability, and then maybe how that reduces the need for surveys. You said sometimes it doesn't, it supplements the surveys, but if it seems like it would reduce some of the need for the surveys. So how do the costs play out as far as the technology and the reduced need for surveys?
Yeah, thanks. Thanks for asking that question, and I should have mentioned that earlier. That's actually a key piece of why we're doing this. First of all, thank you for not calling me out on any of my BS on the carbon markets. I was really afraid that that a generalization was going to get called out there. Expert surveys are very expensive. Not only are they infrequent, not only do they have this bias, but they're very expensive. If you're going to do it properly, the Gates Foundation often requires people to hire 1 or 2 staff members to just do M&E, because Gates cares about knowing if they're doing this effectively, but for lack of a better option, they do it by these same surveys, and it's very expensive and time-consuming. And you're right, with carbon projects, it can be extremely expensive to monitor. With Vestergaard, we had 2,000 people on the payroll for several months, for 3 months, just doing monitoring and education work with our program. So, of course, education was a piece of that. So that wouldn't go away, but there's still a significant cost associated with just gathering data. We are working to show that our sensors are not only provide a higher resolution of data, but are cheaper. Our sensors cost $100 and sit in a village for 6 to 18 months before you have to touch them again. They're getting orders of magnitude more data than a survey does, and they're costing far, far, far less. $100, if you're an expert, you're spending $50 a day on gas, you're spending a few $1,000s on plane tickets, hundreds and perhaps thousands of dollars on hotels and food and lots of other stuff. And you spend a couple hours in any given village. Our system, we still have to implement it. We still have to have people that are going and doing these implementations, but they are there for a much longer period of time. So there are two cost savings that we're after, and we haven't proven it yet. So I'm not going to say that we've proven this, but we believe the cost savings are there, and we are working to demonstrate that. And the cost savings are twofold. There's an immediate cost savings when you reduce the burden of your expert surveys. Your experts can cover more territory, so your per sample cost is much lower from the experts or from the people you're training to do surveys. So that's an immediate cost savings. And a much more important longer-term cost savings is that when our sensors identify a challenge or a problem in a program that you didn't know about because your expert survey didn't tell you about, that was a project you were wasting money on, that you spent money on that was not effective. And maybe you would go and continue to put money into it and it continued to not be effective, or you go and put money into a similar program done in a similar way because you thought it worked the first time and it didn't. And that's what we're really after. We're really after showing where there are weaknesses and where we can improve those through having this instrumented data and thereby making donor, investor funds more efficient. So we're trying to do that. And I'd love to talk to you later about Windrock. Any other questions? Okay, well, thank you all for your time. I appreciate it.
Thank you. There are some refreshments back there, so we can spend some more time talking to Evan. Thank you.
Thank you. Hi.